Hello dear students, welcome to ECE Academy Benefactor. In this class, we will be seeing hybrid model, which is also known as H model of the transistor amplifier circuit. So why do we need H model? To do the analysis of a transistor when connected as an amplifier. The complexity of the analysis of transistor amplifier is that why there is complexity while doing analysis is because transistor is a non-linear device and establishing analytical relation between output and input is too difficult without modeling. So while doing the analysis of a transistor as an amplifier, it's difficult to, so we need a model for it, for doing its analysis. Why it is complex is because transistor is a non-linear device. The most suitable metrics of a two-port network to describe the transistor amplifier circuit is hybrid parameter model. We have seen how to draw the model. These are the notations recommended by IEEE standard. So input side is I. The first number is 1, 1, 1, 1, 2. So I is input, 2, 2 means O, output. F means forward transfer, 2, 1. R1, H12 means reverse transfer. Okay, this is how we need to remember. So we can connect the transistor in 3 configurations: CB, CE, CC configuration. How to use the notations now? So what are the parameters used? At the input side we are having H11. The first number 1 is at the input. 1, 2 means these two are input parameters, H11, H12. Then comes at the output side H21, H22. 1 means input, 1 first parameter, input second parameter, 2 means output first parameter, 2 means output second parameter. So for coming to, so what is H11 IEEE notation? H11 is I. This is I. Notations are given I. H12 is R. H21 is F. H22 is O. These are the IEEE notations. So coming to CB, the last letter will be B. So it will be HIB, HRB, HFB and HOB. Coming to CE configuration, the second letter will be E. HIE, HRE, HFE, HOE. Okay, so I, R, F, O. If you can remember, I, R, F, O. Coming to CC configuration, HIC, HRC, HFC and then HOC. The most suitable model is hybrid parameter model or H model. This model is also referred as low frequency small signal model of transistor amplifier circuit. I hope it's now clear. So why do we need to draw the H model? The H model full name is hybrid parameter model. Why we need to draw H model of transistor? Because when we are doing analysis of transistor as an amplifier, we need to do its modeling so that we can easily do its analysis. Why it is more complex is because transistor is a non-linear device. So it is also referred, this H model is also referred as low frequency small model. In amplifier circuit analysis, the parameters of importance are voltage gain, and we are doing analysis. What we need? We need voltage gain AV. We need voltage gain AV. We need current gain AI and input resistance Ri, or sometimes also known as input impedance and output resistance. So while doing analysis of transistor as an amplifier, we need these parameters. So it is done using a two-port network. So transistor, this is represented by a two-port network. Input side voltage is V1, the output voltage is V2, current input is I1, and the output side current is I2. This is how we draw the H model of or two-port network model. So we are replacing this two-port network by these four parameters H11, H12. At the input side, we are using the first number as 1. In the output side, we are using the first number as 2. So we have to remember H11 means this parameter belongs to the input side. H12, this parameter belongs to the input side. So we are having input voltage, this is input port, V1 input, I1 current, H11, H12, V2. At the output side, we are having a current generator, H21, I1. This I1 is what? The current flowing here, H22. And the current I2, the output voltage is V2 here. So this is how we need to draw the H model of the transistor as a two-port network. I hope the notations are clear. HIB, HRB, HFB and HOB. The hybrid equivalent for a transistor consists of Thevenin equivalent circuit at the input. Thevenin means a voltage source is there. As we have seen the equivalent circuit, voltage source is there at the input side. So there is a voltage source, it is known as Thevenin equivalent circuit at the input, and there is a current at the output side. So we say it's a Norton equivalent. So this hybrid equivalent circuit consists of Thevenin equivalent circuit at the input side and Norton equivalent circuit at the output side. Now what are the relations equating the input output voltages and currents in a transistor are given by? So here we have to know the two basic equations. One is the input voltage, other equation is for the output current. So for finding the input voltage equation, we need to write the KVL. What is the KVL? V1 is equal to I1 H11 plus H12 V2. We are traversing in this direction. So we got the first equation, H11 I1 plus H12 V2. Now the second equation for at the output port is I2. Now what are the current entering is equal to current leaving. So this is current is entering here. So what are the leaving currents? H21 I1 plus H22 V2. These two are the leaving currents. The second equation is for I2, that is H21 I1 plus H22 V2. So these are the some important equations relating input voltage. And coming to the limitations of H parameters, there are two major limitations. By using H parameters, we can use only for small AC signal analysis, and its name is, as we have seen, it is a low frequency model. Why we are using it for small AC signal analysis? Because the transistor behaves as a linear device for small signals only. So second point, it is very difficult to get the exact values of H parameters for a particular transistor. It is due to the fact that the H parameters are subject to considerable variations due to change in junction temperature and variation due to change in operating point. So due to changes in junction temperature or due to changes in operating point, and the H parameter values are subjected to vary. So it's very difficult to get the exact values of H parameters for a particular transistor. So that these are the two limitations. It can be used for small signal analysis, and the H parameters exact values are difficult to get. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.